Right, neat question here. Slightly different to your typical question involving differentiation or integration, because we're actually given the graph of dy by dx, and we're also given the second derivative. We have to work our way backwards to finding y over time. So we've got the dy by dx squared is equal to 3x squared plus 2 for all values of x, and it's given that C has a single stationary point. Determine the nature of the stationary point. Well, we can look at the second derivative for that and just see if it's going to be positive or negative. And actually, 3x squared is always positive or 0, greater or equal to 0, whereas 2 is always greater than 0. So overall, d2y by dx squared is greater than 0, so the stationary point is a minimum. One way I like to think about this is that what is actually happening, well, I know the gradient is becoming 0, but when you look at the gradient, it's actually increasing. It's negative, it's getting bigger and bigger, it's 0, and then it's positive. So that's why it makes sense that if it's bigger than 0, it's a minimum, and if it's less than 0, it's a maximum. Maybe I should just write here for all x. In B, we're given that the curve C passes through the point -1/4, and we're asked to find C. Well, the first thing is that we need to just find dy by dx, and that's going to involve some integration. So actually, dy by dx is going to be the integral of the second derivative. You don't normally write this, but that is what we're doing. And so I'm going to raise the power by 1 and divide by the new power. So it's actually going to be 3 divided by 3, which is going to get x cubed, and then plus 2x plus some constant c. But I can see when x is equal to 0, the first derivative is equal to 3. Okay, we've got this condition that fixes what c is going to be. And therefore, c is going to equal 3, because these things are just 0 when x is 0. Brilliant. So dy by dx is actually equal to x cubed plus 2x plus 3. Now I can do the same again, integrate to get y. And that is going to be 1/4 x to the 4 plus x squared plus 3x plus another constant. I'm going to call it k this time. I don't want to call it c again because I've already dealt with a c. Now I can substitute this in when x equals -1, y is equal to 1/4. Therefore, -1 is going to equal, well, -1 to the power 4 is just 1, so I get 1/4 here. Sorry, I've made a mistake, haven't I? This should be 1/4. Okay, backtrack. So I'm substituting in y is equal to 1/4, which I've done, and then x is -1. So put it into here, and then I'm going to add 1, -3, and plus k. Of course, you can use your calculator as needed here. These are actually going to cancel, so I'm going to get 0. So this is going to give me -2, and therefore k is equal to 2. And my final answer is therefore y equals 1/4 x to the 4 plus x squared plus 3x plus 2. Nice.